All right, here we go. 7.3, Algebra 2. Logarithmic functions and inverses. Okay, what is a logarithm? The logarithm is the inverse of the exponential function. Okay, we're going to get into that more, and you'll see it when we start graphing it, but because they're inverses, the x and the y switch, right? So that's kind of what they did right here. I think this is a little confusing the way they wrote it up, but basically you're looking at exponential growth. Okay, b is bigger than 0, and it's not 1. It could be decay too. We're pretty much going to look at exponential growth, and the logarithm being its inverse. Okay, so the exponentials and the logs are inverses, so x and y are switched. That's why this kind of looks funny. I like to think of it like this. Okay, since y equals bx, that's the way we talked about exponential functions. Then the log base b, there's my base b, okay, of y, this right here, equals x, my exponents. That's what we use the log for, okay? The log finds the exponent when we don't know it. When you get something like 32 equals 8 to what power, and we'll look at that later, and you don't know what power it is, and 8 doesn't, 8 times 8 times 8, it doesn't go into 32. So it's going to be some kind of fractional form. Well, how do you find that? How do you find a fractional form for an exponent when you're looking to find something raised to a fractional power to equal something? Well, what you do is you switch it to the log, okay? And when you want to find the log of something, you normally switch it to the exponential form. Because they're inverses, they kind of work hand in hand. What I mean is this. How do you write a log? If I had 100 equals 10 squared, which we know it does, how would I write that as a log? We'd say the log base 10 of 100 equals what? Okay. Well, if I didn't know that exponent, I could put that into a calculator and figure it out. Okay. If 10 didn't go into that evenly, how would I find it? I'd write it as a log here, and then I could punch it into a calculator, and my answer would be the exponent. All your calculators are base 10. Okay. So I could just go log of 100 and hit the enter button, and I'll get 2 for an answer. It'll tell you what the exponent is. Okay. It'll tell you that base raised to that power equals that. Just like 6 squared is 36. Okay? There's my y, there's my b, there's my x. Just plug it in and go. But they work hand in hand. We use the log to find that exponent when we don't know it, when we can't just easily find it. So let's look at some examples here. Okay, we've got that there. Now what if you want to evaluate the log? What if you want to go the other way? What if I gave you the log base 8 of 32? What does it equal? In my mind, I'm thinking 8 to what power equals 32. So that's what I want to do first. I want to write this as an exponent. I want to take this right here. There's my b, there's my y, there's my x. 32 equals 8 to the x power. Okay? Now, 32 to the first power, or 8 to the first power is 8. 8 squared is 64. We're already past 32. So some fraction between 1 and 2 is my exponent. How do I find it? Well, what you want to do next, once you write an exponential form, is find a common base between these two. Okay? And in our case here, 2 is that common base. I can write 32 as 2 to the 5th power, because 2 to the 5th power is 32. 8 is 2 to the 3rd power, and then it's raised to the x power. Okay? And we know from our exponents that 3 times x is 3x, because when you take a power and raise it to a power, you multiply. That's back in your notes there from chapter 6. So 2 to the 5th power equals 2 to the 3x. Well, when your bases are the same, then the exponents have to be equal if these two are going to be equal. So step 3 is set the exponents equal and solve for x. Set 5 equal to 3x. Divide the 3 out. X is 5/3. And isn't 5/3 between 1 and 2? Sure is. Okay? So that's the big thing about finding those exponents. Okay? Is using the log to do that. When they give us the log, we can go to the exponent. When they give us the exponent, we can go to the log. You'll see how that works when we start looking at some of the work. Okay? They work hand in hand. Well, what about the graph? Just like we've been doing. Okay? Not much different. They are inverses, so they do reflect over the y equals x. Remember, you can switch x and y. Okay? So if I had y equal to 10x, my a would be 1. That's exponential growth. It would look like this. Okay? Represented in a log, it'd be log base 10 of my y would equal my exponent. Okay? And remember, you just switch the x and the y's. So if I'm going through the point 0, 1, then I have to go through the point 1, 0 for its inverse, the log. Okay? And you can switch each of those points. You get out here, you might have negative 100 over some real small y. So now you're going to flip it, and you're going to get some real small x over a negative y, a big negative y. So they flip. Okay, it reflects over it. This is what the graph of the log would look like. Okay, coming off of exponential growth, this is the log. X equal to 1 is our start point. Okay, from where we're going to move our graph. When we talked about exponential functions, y equal to 0, or the x-axis was the asymptote. Switch it now. Flip the x and the y. Now the y-axis, or x equals 0, is our asymptote. We're going to get ever so close to that, but never touch it. Okay? Let's look at that graph. So here we are. We want to translate y equals log, or graph, translate log, and graph it. Y equals log base 4 of x minus 2 plus 6. So we know from graphing this, we're going to go opposite here. We're going to go 2 to the right, correct? And then we're going to go up 6. And we're going to do that from our point 1, 0. That's what the log does. So I'm going to go 2 to the right. I'm going to go up 6. 1, 2, 3, 4, 5, 6. So I'm going to be somewhere right here. There's my point. Okay? Now, anytime you move right or left, remember this was my asymptote. So if I moved over 2 to the right, I also have to move my asymptote over 2. So now x equal to 2 is my asymptote. With exponentials, if I moved the graph up or down, I would have to move from here up or down the same number that I moved up or down. But now we're talking about its inverse log, so it's the y that gets moved, or my x that gets moved over. Okay, instead of y moving, it's the x that gets moved over. And once I've got that, I know this is an asymptote. I go ever so close to it, but don't touch it. Coming through here, boom. There's my graph of the log of that guy. Okay, you're still going opposite right or left. You're still going up or down, depending if it's positive or negative. But you're starting from x equal to 1. I moved over 2, went up 6, bam, there I go. And then I just run my graph through it. I move my asymptote over, I'm good to go. Okay, we're going to look at more of that in class tomorrow. Don't make a big deal about it, because it moves just the same. Our log function's always going to look like this as far as we're concerned. Okay, we're not reflecting or anything like that. All right, we'll get after that tomorrow. See you in class. Have a good one. Bye.